Hi everyone, today I'm going to be talking about bioprinting and bioink, which is a major component of what makes the whole process of bioprinting possible. You might have heard about 3D printing, also known as rapid prototyping, which is done by 3D printers creating three-dimensional models, layer by layer using materials including fibers, nylon, silver, wax, polymers, and other plastics and metals. You might have also heard about the possibility of making parts of our bodies using stem cells to create prosthetic organs, including hearts and eyes. Well, although we have a long way to go before we can create full organs, scientists and researchers are developing the area of bioprinting to make basic structures. What is bioprinting, you ask? Bioprinting, similar to 3D printing, is the process of using bioink to create computer-generated models of living tissue, blood vessels, bones, and more for the use of medical tests and research. This can potentially prevent testing drugs on humans and animals by using printed structures instead. There are a few main types of bioprinting, which are extrusion, inkjet, and laser printing. In extrusion printing, various amounts of pressure are used to push bioinks through gauges or pinhead nozzles of specific diameters. After the model is printed, the biogel is solidified on the outside by either chemical means or regulation of temperature. In inkjet printing, tiny droplets of gel are ejected onto a substrate, and as temperature varies, the different sizes of droplets are produced. In laser bioprinting, laser beams are used to control the droplets of ink to build layers on substrate. Because cells can be distorted by some of these methods, especially extrusion printing, there are several components to bioinks that truly affect the viability of a structure. Bioinks must have the right amount of viscoelasticity. This refers to the ability to hold the structure once it's printed. Think about jelly. What is the consistency like? Wiggly, right? But still strong enough to hold shape. This will help protect cells from shear stress, which happens in effect of bioink passing through the nozzles at high pressure, which causes shear thinning and the contortion of cells. Bioinks must also hold millions of cells, and to do so it must provide the proper conditions for cells to form tissues. Bioink must be made without contamination and be kept sterile. It must retain water and have the properties of a hydrogel. Soy or agarose, which is a seaweed extract, are used to keep the material firm but also bouncy enough for cells to live and grow. Biogels are also filled with basic proteins and other substances to sustain life. Bioprinting has allowed the discipline of tissue engineering to take a step towards working with biomaterials and structures that can be used for a variety of reasons in medical research. Hopefully in the future, we can use manufactured tissues, bones, skins, and blood vessels in bioengineering labs around the world for the progression of medicine. And perhaps now you're just as eager as me to maybe even see full organs being created for many noble reasons.